Integer, float, complex. There are three distinct numeric types: integers, floating point numbers, and complex numbers. In addition, booleans are a subtype of integers. Integers have unlimited precision. Floating point numbers are usually implemented using double in C. Information about the precision and internal representation of floating point numbers for the machine on which your program is running is available in sys.float_info. Complex numbers have a real and imaginary part, which are each a floating point number. To extract these parts from a complex number z, use z.real and z.image. The standard library includes the additional numeric types fractions.fraction for rationals and decimal.decimal for floating point numbers with user definable precision. Numbers are created by numeric literals or as the result of built-in functions and operators. Unadorned integer literals including hex, octal, and binary numbers yield integers. Numeric literals containing a decimal point or an exponent sign yield floating point numbers. Appending J or capital J to a numeric literal yields an imaginary number. A complex number with a zero real part which you can add to an integer or float to get a complex number with real and imaginary part. Python fully supports mixed arithmetic. When a binary arithmetic operator has operands of different numeric types, the operand with the narrower type is widened to that of the other. Where integer is narrower than floating point, which is narrower than complex, a comparison between number of different types behaves as though the exact values of those numbers were being compared. The constructors of integer, float, and complex can be used to produce numbers of a specific type. All numeric types except complex support the following operations. For priorities of the operations, see operator precedence. Operations. Operation result notes full documentation. X plus y, sum of x and y, x minus y, difference of x and y, x multiplication y, product of x and y, x x division y, quotient of x and y, x slash slash y integer, float quotient of x and y, x percentage y, remainder of x divided by y, minus x, x negated, plus x, x unchanged, abs absolute value or magnitude of x, integer x, x converted to integer, float x, x converted to floating point, complex real comma imaginary, a complex number with real part re, imaginary part im defaults to 0. C dot conjugate of complex number c, div mod x comma y, the pair x slash slash y comma x mod y, power xy, x to the power of y, x multiply y, x to the power of y, x to the power of y. Notes, also referred to as integer division, for operands of type integer. The result has integer. For operands of type float, the result has type float. In general, the result is a whole integer. Though the result's type is not necessarily integer, the result is always rounded towards minus infinity. 1 slash slash 2 is 0, minus 1 slash slash 2 is minus 1, 1 slash slash minus 2 is minus 1, minus 1 slash slash minus 2 is 0. Not for complex numbers. Instead, convert to floats using ABS if appropriate. Conversion from float to integer truncates. Discarding the fractional part, see functions math.float and math.ceil for alternative conversions. Float also accepts the strings NaN and inf infinity with an optional prefix plus or minus for not a number nan and positive or negative infinity. Python defines power 0, 0 and 0 multiplies by power 0 to be 1, as is common for programming languages. The numeric literals accepted include the digits 0 to 9 or any Unicode equivalent code points with the ND property. See the Unicode standard for a complete list of code points with the ND property. All numbers dot real types integer and float also include the following operations: math dot trunc x, x truncated to integer; round x, bracket comma n bracket, x rounded to n digits, rounding half to even. The n, if n is omitted, it defaults to 0. Math dot floor x, the greatest integral less than equal to x. Math dot sil x, the least integral greater than equal to x. For additional numeric operations, see math and see math modules. Let's see the examples. A is equal to 1, b is equal a is equal to 10, b is equal to 100. Print a plus b will print 110. Print a minus b will print should print minus 90. Print a into b should print 1000. Print a divided by b should print 10 by 0.10. Print a divided by let's see. Here we can see the same output. Now change the value here to 1 and here 2. Print a divided by 2. A divided by b will print 0.5. Print a divided b will print 0. Print a percentage b will print 1. Let's see, it's a reminder. Here you see. Okay, so this was about division. Print minus a will print minus 1. Print plus a will print 1, and if this is minus, print minus a will print a, that is 1. This is true, absolute. Minus 1 abs a will print 1. Okay, integer x, for example, we store a floating point number 1.5, and here we say integer, it will convert to integer, that is 1. And if we say float, it is already float, so it will print 1.5. And if I say complex which has 1 comma 9, so it will print imaginary number 1 plus 9j. C dot conjugate number c. If I store c is equal to this and try to print c dot conjugate, it will print 1 minus 9j du mod the pair. So if I print du mod and here I say 1 comma 2, it should print 0 and 1. Yeah, so this is quotient and this is remainder. And power x a power 2 comma 3, which results into 8. So let's run it. Okay, I didn't print it, so let me print it. Now it should print 8. Then x, this is also a simple power, same, print 2 power 3, it will print 8. Import math dot cell, that is 4.5, and let's print so it should be 5. If I say 4, it should print 5. And if I say math dot floor and here I say 4.5, it should print 4. Yeah, that is standard math operation. Round, print round. If I say 4.6767 this and round to 2 decimal points, so it should be 68, 4.68. Yep. And if I say 3, so 3 decimal point, that should be 4.679. Here 4.679. And math dot trunc, print math dot trunc. If I say 4.5, so it will truncate, and I think print only 4.5 is truncated. So this was about numeric types. Thank you.